The last thing we need to learn in our chapter on parabolas is how to graph a parabola if you are given the equation in general form. Because if we're given the equation in general form, it's helpful to figure out what the vertex is before we start graphing. So just to recap, the general form for a quadratic equation, which is a parabola, is y equals ax squared plus bx plus c. And again, please make sure you're filling out these notes as this video is going. We need a formula. The formula for the x-coordinate of the vertex. So just remember, it's the x-coordinate of the vertex. X is going to be equal to negative b divided by 2 times a. So this is a formula that we're going to use over and over and over again. And what you're really going to find out is it is a lot of just algebra. Can you find an answer when you plug numbers into a formula? And so we're going to practice some of that on the next 2 examples. In example number 1, we're supposed to find the vertex of this parabola, and we want to write our answer as an ordered pair. So the first thing that I'm going to do is I'm going to write down what my a, b, and c values are. In this problem, a is the number associated with the x squared, which is a 1. B is the number associated with the x term, and it is positive 2. And c is the constant term at the end, remember signs included, negative 3. So to figure out what the x value of the vertex is, I'm going to use my formula. X is going to be equal to negative b divided by 2 times a. So let's plug in our numbers. So x is going to be equal to negative 2 times 2 times 1. Notice that whenever I plugged in a number, I put it in parentheses. So the 2 for the b value is in parentheses, and the 1 for the a value is in parentheses. The top of my fraction is negative 2. The bottom of my fraction is positive 2. And if I take a negative 2 divided by a positive 2, my answer is negative 1. So the x-coordinate of the vertex is negative 1. And I'm really ready to start to write my vertex. My vertex is negative 1 comma something. The next step is to figure out what that something is. In order to figure out the y value of the vertex, I need to plug in that x value into my original equation. It's just like if I was going to make an xy table to graph something. So y is going to be equal to negative 1 squared plus 2 times negative 1 minus 3. Order of operations tells me that I need to do exponents first, so I need to do negative 1 squared first. That's 1. 2 times negative 1 is negative 2, and then I have this minus 3 at the end. 1 minus 2 minus 3 is negative 4. So the coordinate of my vertex is the coordinate point, negative 1, negative 4. Let's do exactly the same thing in this next example. So the first thing I'm going to do is figure out what my a, b, and c values are. A is the number associated with the x squared term, which is a negative 3. B is the number associated with the x term, and I don't have an x term, so b is 0 in this case. C is the number associated with the number at the very end, which is negative 2. So the formula for the x-coordinate of the vertex is negative b over 2a. Let's plug in our numbers. We're going to have negative 0 divided by 2 times negative 3. Negative 0 is just 0 divided by negative 6, and if I take 0 divided by negative 6, I get a x-coordinate of 0. So for my vertex, it is the coordinate 0, comma, something. Now let's figure out what the something is. I need to plug 0 back into my original equation. So y is going to be equal to negative 3 times 0 squared minus 2. Order of operations tells you to do exponents first. 0 squared is 0. Negative 3 times 0 is still 0. So I have 0 minus 2, which simplifies to negative 2. So the vertex is the coordinate point 0, negative 2. On the last page, we were finding the vertex of a parabola, and on this page, we're going to be graphing a parabola. Now, I will tell you that I am helping you out a little bit, because if you've remembered when we've graphed stuff before, if we can get the vertex of our parabola right in the middle of our table, then we're going to end up seeing some symmetry in our table. And I am giving you the vertex in the middle of the table, so we should notice some symmetry. So let's try to graph number 3. The first question says it's supposed to say which way does it open? And I'm going to look at what my A value is. And so in my equation, A is the number associated with the x squared term, which is a 1. Since it is a positive 1, that means that my parabola is going to open upward. Okay, just keep that in mind. Now, in order to graph this, I think it's nice to show work in the middle here. So 5 different times, I'm going to have something squared minus 6 times something plus 9. And so I'm going to write this same thing a few times. Something squared minus 6 times something plus 9. Once I have all of that filled in, let's plug in the numbers that I'm going to plug in each case. And so I'm going to plug 1 in the first row, and I'm going to plug 2 in, and 3, and 4, and 5. So let's go ahead and get started. Remember the order of operations. We need to do exponents first, and we have to do some work in our head. I have to take 1 squared first, which is 1. And then I'm going to have minus 6 times 1, which is minus 6. And then I have plus 9. So that's what I'm actually physically writing out, but it'd be a good idea if we could try to do some of that in our head. 1 minus 6 is negative 5. Negative 5 plus 9 is positive 4. So my first coordinate is 1, 4. In the second row, I have to do 2 squared first, which is 4. Negative 6 times 2 is negative 12, and then plus 9. So 4 minus 12 is negative 8. Negative 8 plus 9 is 1. If I plug in 3 squared is 9. Negative 6 times 3, negative 18. And then I have plus 9. 9 minus 18 is negative 9. Negative 9 plus 9 is 0. Remember, the vertex is in the middle of the table. I should expect my next answer to be 1. Don't just automatically assume that. Let's actually calculate it, just to make sure we didn't make a mistake earlier. I have to do 4 squared first. Remember, 4 squared is 16, not 8. Negative 6 times 4 is negative 24, and then we have plus 9. 16 minus 24 is negative 8. Negative 8 plus 9 is 1. Good. 5 squared I have to do first. It's 25. Negative 6 times 5 is negative 30. And then plus 9. 25 minus 30 is negative 5. Negative 5 plus 9 is positive 4. So let's take all these points. We should end up with a parabola that opens upward. Let's go ahead and plot these. Let's plot the coordinate 1, 4. Go to the right 1 and up 4. 2, 1. Go to the right 2, up 1. 3, 0. Go to the right 3, stay there. 4, 1. Go to the right 4, up 1. And 5, 4. Go to the right 5 and up 4. Looks like I do have a parabola that opens upward, so let's try to draw in the best parabola that I can. And I think we can call number 3 graphed. The only thing that's going to make this next example a little trickier is the fact that I have a negative number in there, but that's the only thing. Let's determine which way this opens. My a value is the number associated with the x squared, and it is negative 2. Since a is negative 2, since it's negative, it tells me that this parabola is going to open downward. So let's just keep that in mind, and hopefully we get a parabola that opens downward. The first thing that I'm going to do is fill in each row the math that I need to do. So I'm going to have to do negative 2 times something squared plus 4 times something plus 6. And I'm going to end up writing that same thing the next 4 times. So pause the video, write that 4 more times, and then we'll resume in a second. Once we have everything filled in, now let's plug in the numbers that we're going to be working with. In the first one, I'm going to plug in negative 1 in my blanks, and I'm going to plug 0 in, and then positive 1, positive 2, and positive 3. Again, I'm being nice in this problem, just like on the homework problems, and the vertex for your parabola is this point right in the middle of your table. So we should notice some symmetry when I'm all done. Now, we can calculate these in any order, and I would personally calculate this one first, the 0. Might as well. We have to do 0 squared first. 0 squared is 0. Negative 2 times 0 is 0. Plus 4 times 0, which is still 0. Plus 6. So 0, 6 is one of my coordinates. Let's go downward, so let's plug in the 1 next. I have to do 1 squared, which is 1. Then I have to take negative 2 times 1, which is negative 2. Then I have to do 4 times 1, which is 4, and then plus 6. Negative 2 plus 4 is 2, plus 6 is 8. For this next one, if I plug in 2, I should get 6 for an answer. Let's see if we do. 2 squared is 4. You've got to do that first. Then I have to take negative 2 times 4, which is negative 8. Now let's do 4 times 2, which is positive 8. And then we have plus 6. Negative 8 plus 8 is 0. 0 plus 6 is 6. Let's plug in 3. 3 squared is 9. Then I got to take negative 2 times 9, which is negative 18. Then do 4 times 3, which is 12, and then plus 6. Negative 18 plus 12 is negative 6. Negative 6 plus 6 more is 0. So that tells me when I plug negative 1 in, I should get 0 for an answer. Let's see if I do. I got to do negative 1 squared first, which is positive 1. Negative 2 times positive 1 is negative 2. If I take a 4 times a negative 1, I get a negative 4, and then plus 6. Negative 2 minus 4 is negative 6. Negative 6 plus 6 is 0. So let's go ahead and plot these points, and hopefully we end up with a parabola that opens downward. Let's plot the point negative 1, 0. Go to the left 1 and stay there. And then let's plot the point 0, 6. Start at 0, 0, go up 6. One, 8. Go to the right 1 and up 8. Two, 6. Go to the right 2, up 6. And 3, 0. Go to the right 3. This does look like a parabola that opens downward, so let's try to draw the best parabola we can. And I think we can call that one graphed. In this very last example, I would like to think about whether the vertex of this parabola is the highest or lowest point of the parabola. So let's determine which way this opens. My A value for this one is positive 3. Since A value is positive 3, that tells me my parabola opens upward. So I have a parabola that looks like this. I am interested in the vertex of the parabola. Here's the vertex. And I just want to know, is that vertex the highest or the lowest point on that parabola? Well, once we draw that picture, I think we can tell that that vertex is the lowest point, or a minimum value for the parabola.